Welcome to Properties of Parallelograms. Today's objectives are to prove and apply properties of parallelograms and to use the properties of parallelograms to solve problems. Let's begin by defining what a parallelogram is. A parallelogram is a quadrilateral with two pairs of parallel sides. So a parallelogram is a quadrilateral with two pairs of parallel sides. Whenever we're writing the name of a parallelogram, we use this symbol. So if I was going to name this parallelogram, I would name it parallelogram A, B, C, D. This is how we name parallelograms. Now the first theorem we want to talk about for parallelograms is that if we have a quadrilateral and it's a parallelogram, its opposite sides are congruent. So if we have a parallelogram, then the opposite sides are congruent. So in this picture here, side AB is congruent to side CD, and line segment BC is congruent to line segment AD. There are three more properties of parallelograms that we want to talk about. The first one has to do with the opposite angles. Second one has to do with the consecutive angles. And the third one has to do with the diagonals. Okay, let's talk about the opposite angles first. So, if a quadrilateral is a parallelogram, then the opposite angles are congruent. So here we have angle B is congruent to angle D. And we know that angle A is congruent to angle C. So, if a quadrilateral is a parallelogram, then the opposite angles are congruent. Okay, consecutive angles. So if a quadrilateral is a parallelogram, then its consecutive angles have to add up to 180. So we say they're supplementary. So consecutive angles are supplementary. So for example here, angle A and angle B add up to 180 degrees. Angle B and angle C add up to 180. And so on and so forth. Angle C plus angle D add up to 180. And angle D plus angle A. All the consecutive angles are supplementary. Now let's talk about diagonals. So if a quadrilateral is a parallelogram, then the diagonals bisect each other. So if we have a parallelogram, then the diagonals bisect each other. Meaning they basically cut each other in half. So in this example here, segment BZ is congruent to DZ. and segment AZ is congruent to segment ZC. So the three properties of parallelogram have to do with opposite angles, consecutive angles, and diagonals. Let's use the properties of parallelograms to find each of these measures. So the first thing we have to find is AD. Now, I know that ABCD is a parallelogram. So if I want to find side lengths, I know that AD has to be congruent to BC because opposite sides of a parallelogram are congruent. I know AD is 7x, and I know BC is 5x plus 19. Basically, I'm solving for x. So I subtract 5x from both sides. I have 2x equals 19. So x equals 9.5. But that's not my final answer. What they're asking me for is to find AD. And AD is equal to 7x. So I plug in 9.5 for x, and I have segment AD equals 7 times 9.5, which equals 66.5. Next, I have to find the measurement of angle B. Now I know that consecutive angles of a parallelogram have to be supplementary. So I know the measure of angle B plus the measure of angle A has to equal 180 degrees. So I have values for B and A, so I just plug those in. So I have 6y plus 5 plus 10y minus 1 equals 180. I combine like terms, and I have 16y plus 4 equals 180. Subtract 4 from both sides, I have 16y equals 176. Subtract 16 from both sides, and I have y equals 11. They're asking me for the measure of y. So I take y value and plug it right in here to find the measure of b. So the measure of b equals 6 times 11 plus 5. So the measure of b equals 66 plus 5, or 71 degrees. In the previous slide, we used our first two properties of parallelograms. Let's use our property of diagonals to figure out the measures here. So, since EFGH is a parallelogram, I know that the diagonals bisect each other. Which means that segment FJ is congruent to JH. So FJ is 4z minus 9, and that's equal to 2z. I isolate z, so I have 2z equals 9. So z equals 4.5. So this is my first variable. Let me find w. So similarly, EJ is congruent to JG. I know EJ is 3w, and that's equal to w plus 8. I isolate w, I have w times 2 equals 8. So w here equals 4. Now the problem is asking us to find each measure. So the first measure I want to find is FJ. So FJ is 4 times 4.5 minus 9. 4 times 4.5 is 18. 18 minus 9 is 9. So FJ equals 9, and so does JH. So that takes care of those two segments. For the next one, we have GJ, which equals W plus 8. We know that W equals 4, so GJ just equals 12. And so does EJ. So we found all 4 measurements for this parallelogram. Alright, well that's going to be the end of our video for today. Thank you and take care.